We'll just wait for our other presenter before we get going. I'm really excited that you guys get to hear this story.
Yes, it is a good story to tell. We're excited to tell it. It's been told many, many times by us, and we're happy to keep telling it.
Well, this should be a good one.
Well, and if we're running a little behind, actually, Tyler's on the back end of the presentation. So if you want to get started, Stacia, you could probably begin.
Well,
If
and
you
I
guys
have some
think it's a good idea.
introductory stuff to say, so that's probably good
Yeah,
advice, Dante.
Yep.
All right, so let's get going then, everyone. Welcome to our 30th quarterly Northeast Digestion Roundtable meeting hosted by NEBRA, the Northeast Digestion, the Northeast Biosolids and Residuals Association. Since April 2016, NEBRA has been sponsoring these quarterly meetings to share technical and operational experiences and advance best practices for anaerobic digestion. This isn't a webinar, it's more of a meeting or a roundtable format, kind of informal. So we'll have a presentation here shortly from the City of Columbus, and then we'll open it up for questions and discussions. And I know the presenters value the feedback they get sometimes from these roundtables. So I'm going to ask everyone to mute yourselves and remain on mute till after the presentations, and then you can raise your hand, come off mute. There's also a chat function I'll keep an eye on if you want to type things in as they occur to you. This session is being recorded, and after I get it edited, the link will be shared with you next week and posted on the Netter website. So today we're going to be hearing from the City of Columbus. It's a city that is transforming itself in many ways, including really focusing on the greenhouse gas impacts from the anaerobic digestion operations. Columbus engaged consultants to do a study that I believe, or it's believed to be the first multi-sensor fugitive methane study in the Western Hemisphere. It really takes guts to look under the hood like that, especially in a public utility setting. And because if you find it, you need to fix it. So kudos to the City of Columbus. We're going to hear all about the City of Columbus's study and their plans to fix what they found from Stacia Eckenweiler. She's the Assistant Administrator at the Division of Sewerage and Drainage under the Department of Public Utilities. And joining her are Tyler Schweinfurth and Dante Fiorino. Tyler works with Stacia as a project manager for the City of Columbus, and Dante is a senior principal engineer with Brown and Caldwell. They're all on LinkedIn, so that's all I'm going to say about that because I want to get going. So I'm going to go ahead and ask whoever's taking the lead to go ahead. And as a reminder, it's intended to be more informal than a webinar, so we definitely want to leave some time here for questions at the end. All right,
Absolutely.
Go ahead and take it away.
Thanks. Yeah, appreciate it. Appreciate the opportunity to talk with everybody. So Janine, when you say, when you find something, you gotta fix it, right? Well, I would say, the key thing here is that we wanted to be the ones to find it, right? We didn't want somebody else finding it and then coming to us and saying, you got a problem, right? So at least if that ever were to happen, we'd have, the results and the information hand over and be like, yes, we're well aware and we're working on it now. So I think that's something to probably keep in mind as we go through this, because I think a lot of the folks on the call might have the ability to actually start looking into this and making themselves aware so they're not being told by somebody else that there's a problem. So, all right, well, so am I just going to tell you next on the slides and then you'll advance them, Janine? Okay, perfect. All right,
I'm actually
Dante's in charge. He's driving.
All right,
I'm in charge. Ooh.
Go next. All right, so just few areas we'll go into real briefly: introduction, investigation, solutions, and questions. Typical presentation format, but something to point out here is that this effort and this analysis was actually featured in now a couple issues of WE&T. The first one was back in September of 2023 when they were highlighting the use of drones in various ways, and our project was one of the things that was actually highlighted, to show one of these really novel uses of drones, although I don't know, they're being used for everything now. So not surprising that this was one of the ways that we were able to utilize to help us through this journey. There has been a follow-up article since then too in the I think the September issue of this year as well. So for those of you who have access to these, pull them out and read them after this presentation if you're interested in getting more information, because they're pretty cool. So next. All right. So, methane, right? Methane's a pretty powerful greenhouse gas. We hear a lot about CO2 and, that's really what's having the big impacts in our atmosphere today. And it is. But, some things to point out about methane is, it's over 80 times more powerful than CO2. So it has a huge upfront impact when it's emitted into the atmosphere. Over time, that impact actually kind of attenuates and dissipates, whereas CO2 stays, present in the atmosphere. But, something to think about, being able to mitigate methane in the atmosphere will help reduce those immediate, impacts that we do see that are attributed to greenhouse gases in the atmosphere. So if we could do something about that now, we could really help that journey, with greenhouse gas reduction overall. And then, of course, over time, we address the CO2s, the nitrous oxides, and the other ones that are out there that are still causing problems as well. And something to keep in mind for us too, methane, it's fuel, right? So that's going to be something to keep in mind for the future parts of this presentation as well. So, when looking at this particular effort and trying to determine, what would drive this effort, why do we want to do this? Why is this important to us? We've got a lot of things that we'll evaluate when it comes to, projects and the different aspects that we like to keep in mind when we're scoping and moving through projects. The first one is, safety, right? Well, odors and safety, if you want to hit the next, but yeah, we got a little animation, so they're gonna be hard to work through with three of us doing this. Odors and safety, so methane, right? It's a gas, and it's a highly flammable gas, and it causes safety concerns at our plants. Maybe not as much odor concerns as maybe some of the other odors that come out of our facilities. But we know, what we thought we knew, certain areas of our plants that had these concerns for safety, right? What we found on this is that we have those concerns in a lot more places than we thought. So that was one of the huge drivers for doing this. Public awareness, that was one of the next ones, right? And this will tie into what I started this off originally saying, right? Like, we want to know we have the problem. We want to be the first one to know we have the problem, and then to be able to tell the public and others about it. So there are satellites out there that are actually measuring methane, and we'll go to it. Yeah, okay, new slide. So there are satellites that have been, launched into space that are actually traversing, the planet and measuring methane emissions, right? Or mapping methane emissions. These are generally, hosted by or initiated by nonprofits. They're funded by environmental advocacy groups, and they're trying to seek out bad actors, right? They're trying to show where the major emissions are coming from, and holding those folks accountable. So it's this one that's being shown is a group called Carbon Mapper. So they're flying over the country and mapping all these places where these emissions are happening. And recently, I guess, they went over the top 10 largest cities in the country and mapped all of these emissions, and are working on that data, and will be uploading it to their site within the next 3 to 6 months. So they haven't flown over my facilities yet, but they're going to one day, and then that information is going to be made public. And so that was, I'm not going to lie, the fear factor was part of it here. We wanted to know what was going on and see what we could do about it. The other element that was on the slide is our climate action plan. So the city of Columbus and our mayor has actually put out a pretty aggressive climate action plan, aimed at reducing greenhouse gas emissions. So this project, this effort, and then the resultant, findings and outcomes from it align greatly with that, because the main premise of this is that as a city, we're looking to reduce our greenhouse gas emissions by 45% through the year 2030. And then we're looking to be carbon neutral by 2050. So what we're doing here aligns just about perfectly with that. So if you want to next. Yep. All right. So, what we ended up doing to try to, figure out how we wanted to move through this study is, of course, investigate this in a stepwise process. So level one, we looked at our data, right? You just start with what you got in order to help define your problem. And then, this will help us move through identification of where this problem is coming from, and then how we can actually quantify that problem so we can understand how to address it. So we'll go through a couple of the areas that we looked at, some of the data that we do have, because it's probably some of the data that a lot of you have too, and it's a good area to at least start looking to try to scope your own, own issues if they exist. So next. So one of the first areas we looked at, we have a 100% beneficial biosolids, beneficial reuse biosolids program. Very proud of this. We got multiple outlets of where our biosolids will go. One of them is land application, and at least at the southerly plant that we're focusing on here today, we got these 4 giant land application tanks. They're not necessarily open to the air, but they're not sealed, right? Like they do emit to the atmosphere, and they actually do collect, some of the water that, rainwater and precipitation, things along those lines. But we're measuring our solids that go into these tanks, right? And what we noticed over time is that the amount of solids going in is less than the amount of solids, or I'm sorry, more than the amount of solids coming out, right? So we're getting solids reduction in our tank, right? And the fact that these tanks receive rainwater, I mean, that it's not enough to make this big of a difference, right? So how do we reduce solids in our wastewater plant, right? So, well, the process right before this one, our anaerobic digestion process, is where we reduce our solids. Then we thicken them and we throw them in this tank. We don't cool them, we just thicken them and put them right in the tank. And then from this point, the biosolids are loaded out and taken off site for land application. So if these solids are being reduced in this tank, are we digesting in this tank? I mean, we're not creating all the right conditions for it. We're not keeping it heated. We're not creating anaerobic conditions. But, as we all know from Jurassic Park, right, life finds a way, right? So, that's what's going on in this tank. We are digesting, and because of that, we're releasing methane out of these tanks. And as you can see here, is a significant amount of methane. 78,000 standard cubic feet per year. And that is a huge amount of power, I guess, that we could be generating with this as well. So that was one of the first areas we looked at. The second area was our anaerobic digesters. So we have 6 anaerobic digesters, and we monitor and measure the gas that is being produced by each of them, and that is what is being exhibited on this graph. So, what sticks out in this graph? It seems like one of our digesters is creating a lot more gas than the other 5, right? Well, that is the case. And so what's different between these 6 digesters? Well, the one digester that is producing more gas is actually the one of our digesters that has a fixed cover. The other 5 are floating covers. So, now we all know just by, basic standards overall, that floating covers are, they're just by virtue of how they operate, they're going to emit some gases. What we didn't know was how much. And this was the first data point we had to, clue us into that. So this particular digester is capturing about 20% more gas than the others. They're all getting fed the same, it's the same operation. They're all being, adjusted the same way. So stands to reason we could very much be losing that same amount of gas through all 5 of the other ones. And so by our estimates, that works out to about 114,000, standard cubic feet a year. And that's a lot of energy. That's a lot of power loss. And that's a lot of greenhouse gas being emitted into the atmosphere. So those were the 2 big, items that clued us in, right? And if you just go up, and this is a video right here of Dante standing on top of one of our digesters, and you know, you just look down in that annular space and you can just see, and I know this is kind of choppy, but you know, you can just see the bubbles, right? You can just see that biological activity and, you know, all of that gas that is potentially coming out of this small seam that runs around all of our digesters. Everybody knows it. We just didn't know exactly how much it was. And so that was the next step of our analysis, is to figure that out. So we'll work into the investigation now. I'm going to hand it over to Dante to go into a little bit more detail about what that entailed.
Thanks, Stacia. And I presented that piece, and I am literally pissed that I've never done that Jurassic Park quote, because that is my literally favorite Jurassic Park quote. I can't believe it's in the repertoire now. So thank you.
It's going to be a theme in a future presentation, right?
Yeah, there's the next time we do a presentation, your face is going to be on a raptor's body. That's already happening. I'm working on it. So thank you, Stacia. So now we're going to talk about the investigation, and then I'm going to hand it off to Tyler for the solutions. Because what's super unique, Janine had mentioned, it's the first in the Western Hemisphere multi-sensor investigation in the Western Hemisphere. Let's just say it. If anyone else has done it, they're gonna correct us at some point. I've been saying it a lot. Nobody's corrected us yet. So, but what's even cooler, I think, the coolest part about this isn't that they found it, that they did the hard thing that Stacia just walked through. We investigated it. They're fixing it too. And it's all happening very quickly in one project, and it's being done with pretty conventional technology. So with the investigation, the two levels, level 2 and level 3, first we were focusing on source identification with the Konica Minolta optical gas imaging camera. And so that's kind of like the bottom up estimate. You know, we're finding it, we're pointing at it, it's right there. And then the top down estimate is to do better quantification. You can't just find it and then add it all up. It doesn't work that well. They actually will look at the wind direction, and they'll actually capture the methane plumes and quantify that way. So looking a little more into the camera now, the way that it works is actually super interesting to me. It doesn't detect methane, it detects gases that deflect light at the same wavelength that is a problem for the atmosphere. So the same thing that makes methane or water vapor a greenhouse gas, that is what this camera is looking for. It is looking for light being bent at that wavelength through that gas. So it's a very effective way of finding greenhouse gases. And you can see here, it's just a sample. This is a post-digestion storage tank, and apparently nothing there, and there you have it. There's a plume of methane that you can't see. So I'm not sure how many people have seen this presentation, but if you haven't seen our presentation yet, this is the first time you're going to see methane. Here's a couple of examples. This is Columbus. The top is just a picture, and the bottom is showing the methane coming out. And so the first big source that we identified, the post-digestion centrifuge thickening, the methane pouring out. And even if it's not pouring out here, we opened up this hatch and there it is, right? When the hatch, if you close the hatch, it doesn't make a difference. It comes out and then it gets into the room, and then it is taken out for odor control. So the hatch is open just so you can see it, but if you think about it, I actually call centrifuges, they're fugitive methane machines. Their job is to separate water from solids. They do an even better job of separating gas from solids. That's the first thing that comes out. Next thing, Stacia was talking about the BLAF tanks, the post-digestion biosolid storage tanks. In the foreground here is their huge odor control media bed, and all of the piping within the tank goes here, gets piped underneath and comes out, and then there you can see in the foreground methane coming out. This would be about 20% of the biogas produced at this facility is coming out here. Probably about 15% is coming out here. And then you've got, this is their cake load out, so they also do dewatering, and they get it, this is liquid, but then the cake load out is solids. And you can even see, there it is, you know, it's being loaded on into the trucks, and there's methane, quite a bit of methane there, and then that is again taken to odor control. A few more pictures. Oh, yeah, they're all moving here. And actually, let me get my little laser pointer. There we have it. You guys can see that. Should have done that before. So this is a PRV. These rascals, every PRV we look at, we find. So if you're keeping track at home, floating digester covers, lots of fugitive methane. Post-digestion thickening of any kind, centrifuges or anything, a lot of fugitive methane. PRVs, a lot of fugitive methane. And the reason is you can't see or smell it, but all PRVs are designed to be constantly letting a little bit of gas out. People think that it has to be chirping, is what the operators call it. Chirping is like, way worse than this, but it's always happening. And the reason is that our biogas systems are not designed for a high enough pressure to, it's within the range of where PRVs can release. And so maybe fresh out of the box and installed perfectly, they don't emit. There's not a lot of PRVs that we go to and see that are fresh out of the box or installed perfectly. So this is a problem. Now this is super interesting. Here's the annular space that Stacia showed you the picture from the top. And we've got two same digester, but one is not mixing. And then we turned on the mixing. So you can see, I mean, clearly, when there's mixing going on, everyone is aware that there's more biogas produced. Here's another super interesting, crazy thing. We had a structural engineer inspect this weeks before, came out perfectly fine. We just had the camera out and there's a big leak on the side of the digester and it's emanating right into an exhaust fan that leads to the tunnel system. This is a health and safety concern. We were putting together a report. We took this video, we shared it with Tyler, who's going to be presenting in the city. And this is not an explosion proof fan. So that was replaced immediately. That was a health, and there were a couple of health and safety moments that we had that were really important. This was probably the most shocking. But another thing that's really interesting about this, with the camera, you can see what we see live right now. You can see while you're out there. And Trung and I, we could see this leak, but I went up there and touched it and my finger would stop the methane. I couldn't feel it. I couldn't see it. I didn't see a crack. It's really a silent killer. You just have no clue it's there and there's no way you're going to see it. So that was remarkable. Now we're going to pivot to the drone flux, the quantification piece. So the way this works, it's pretty simple from like a technology standpoint. It's a pretty standard drone. They've got a gas inlet and 2 wind sensors. And so what they do is they go downstream of a big plume or a potential plume, and they run a flux wall. That's what they call it. And so this is kind of like a nice graphical representation. But what this is showing here is, okay, well, here's the ground, and they just start to run and they go up a meter. They're Danish, come across, up a meter, come across, and they do that. And they do 3 walls and they average it out, and it's very effective. It's actually a accredited way of measuring methane. The natural and gas utilities are using them, and they have been accredited for multiple countries, including the US. So this is an accepted way to quantify methane. We did that. Our first, the 2 examples that Stacia had offered to you, the digesters and the BLAF tanks, this was our first thing that we wanted to find. They did the flux wall right here. These orange lines represent the wind direction. And so the wind's blowing this way. They did the flux wall right here, and you can see this is the actual real results, and you could see it in real time. And the average of these 3 runs was 50 kilograms per hour. It's less than what the Stacia's, it's actually less than what we would have calculated based on Stacia's data, but it's more than anybody wants, 2,400 cars per year just in this suite. The surprise was, and I've already kind of revealed the surprise, but we didn't expect the centrifuges. I don't know why, we didn't expect it, but we did a bunch of surveys throughout the plant, and this was another very big contributor. And this one was 18 kilograms per hour, which, there's only one source, so it's actually pretty comparable to the prior sources, and another 880 cars per year. And I don't have this Oh, actually I do. So then if you add this all up, we're adding these all up, it gets to about 70 kilograms per hour that we found. And one thing that's, I think, is noteworthy is we checked the waste gas burner, open candlestick style waste gas burner. And actually it was burning pretty efficiently. You expect with any combustion, there's going to be slippage. And it was at about 0.5% slippage, which is less than the EPA assumed 1%. And that would be, just to try to like put into context what the EPA would consider acceptable, or what they expect, what's in your climate action plans for your emissions at any given wastewater plant is typically 1%. That's what they think. That's 4 kilograms per hour. Southerly found 70. And this is not unique. This is not, they're not uniquely bad. They're 20 times more than what you would expect. This is everywhere. Almost every, floating covers are maybe a little unique, but a lot of plants have them. But this is a problem that we have in our industry. And it's causing real problems for the environment. And so, like, what does kilograms per hour mean? I didn't really know until I started getting into this type of investigation more. And so my colleague Nancy Andrews, she estimated, if you have a cogen facility at your plant, how much methane leakage do you need until you start behaving from a greenhouse gas perspective like a fossil fuel power plant? And so if you have, all you need is 7% to be like a natural gas power plant. If you have 15% leakage, you're similar to an oil plant. If you have 19%, you're a coal power plant. The day that we went out there, just with what we found, 15%. If the SCADA is right, which it's probably more accurate because it's over multiple years, but it is theoretical, it would be off the chart. The reality is, I think it's fair to say, Stacia, anywhere here is not acceptable. The city was very motivated. This is not, they're motivated, they're doing the right thing for the environment, and they don't want to be doing this. So I always find that very interesting and informative. And then I'm gonna show, because Tyler's gonna show you with the bioenergy project and the work that Columbus is doing, how much we're gonna have as an impact. But I did want to show you, if nothing was done, if, I already talked about the 70 kilograms per hour. If nothing is done and they continue to grow like we expect in Columbus, the 30-year outlook is 130 kilograms per hour. And at 100 kilograms per hour, they're actually considered a super emitter. And the federal EPA is actually starting to crack down on that. And I did actually look it up. They're starting to issue fines on a per kilogram per hour basis. And if Southerly was fined, which presumably this will happen one day in the future, I can't tell you when, it was actually $75,000 a day. So this is not a trivial amount of methane, and they're dealing with oil and gas people first, and then they're going to deal with landfill people, and then they're going to deal with us. And so doom and gloom, big problem. What do we do? Tyler's going to come and save the day. So Tyler.
So after we saw all of this, negative stuff, okay, the focus on our end really turned to, okay, how are we going to fix it? So we know our major contributors. We've got our floating digester covers. We've got our biosolids holding tank. We've got our thickening and conveyance, and we've got our PRVs. But how do we address each of these individually? Well, for us, the low-hanging fruit here was obviously our digestion system. And yeah, go ahead, Dante, go to the next one. We looked at each area individually and looked at source reduction and capturing and treating. But then next slide. We first looked at our digestion system as a whole, because that's where we found the most emissions coming from. So in our existing state, we hold our solids for 15 days. We are SRT limited at our Southerly facility. We have 6 million gallons of digestion, and we're already holding solids back into our secondaries, just so we're not overloading our solids system. And that's causing the undigested sludge, because we'd like to hold it, that 23 to 28 days. that undigested sludge is working its way through our facility toward the back end, and it's just pushing that methane into some other areas. So if we can digest it in the digesters first, we can solve a lot of issues. So we're looking at doing what we're calling next generation digestion. That involves constant mixing, it's surface withdrawal, it's a longer SRT. We're talking about adding a significant amount more of capacity to the facility to allow us to get to those longer SRT times. We're also looking at fixed digester covers. Let's close up that annular space and capture the gas that's coming out of it. And then as far as the PRVs are concerned, our system's rated at 30 inches of water column. And that's a fairly tight band when you think about how we operate. We're normally at 20 inches of water column. That doesn't give us much flexibility with the digester system to be able to go above that. Once we start going to that 22, 23 inches, the PRVs start to leak. So now we're looking at a 60-inch water column. It doubles the pressure within the system, but it also gives us a wider operating band. So if we're at 20 inches of water column operating, we've still got 40 inches before the PRVs should be emitting, but we know it's probably more around the 50 inches of water column. So it's just a wider operating band for us. So what does the future state look like? Well, we get more VSR digestion in the new digesters and the rehab digesters. That's getting the methane out in the digesters and is preventing a lot of that methane from going downstream. So we wouldn't see as much as dewatering, we wouldn't see as much at thickening, and more importantly, we will not see as much in BLAF. And by just doing the enhanced digestion, we've already reduced down to 94.6 kilograms an hour. That's a significant decrease just through the digestion system itself. But if we fix the covers, if we go to these concrete covers, that's a 36% reduction in our methane emissions. And by going through all these digester improvements, upgrading the covers and adding a biogas reuse, we're getting a 72% reduction in our methane emissions. So it's a significant reduction when you talk about this overall project. And right away, two of the low-hanging fruits here get knocked out right away, our digesters and our PVRVs. We've addressed these known significant contributors. So then we looked at our biosolids tanks, our BLAF tanks. We had several options that we looked at here. We looked at some augmented biofiltration, vapor combustion unit, regenerative thermal oxidizer, doing a fixed concrete cover on the BLAF tank, and also doing a stainless steel cover on the BLAF tank. I'm not going to touch too much on this. The augmented biofiltration is finicky, I guess, for lack of a better term. It doesn't work real well when you start getting outside it's got this nice, easy operating condition. And once you get outside of that with pH, oxygen concentration, moisture content, it really doesn't work as well. So we just didn't see it as a feasible alternative. We looked at this vapor combustion unit specifically for BLAF. This is great. This is used in oil and gas. It works really well at reducing these emissions. But there's only a few that are installed at some wastewater facilities. So then we looked at the thermal oxidation. There's two types. There's low concentration burners, and there's also the regenerative thermal oxidizer, which is kind of the one we honed into here. Great destruction efficiency, still requires some support combustion, and it is a higher cost piece of equipment. Then we looked at potentially putting a fixed concrete cover similar to the digesters on top of BLAF. This was not structurally possible. It's just too heavy. The tanks weren't designed for this originally, so this was, thrown out relatively quick as well. And we also looked at a stainless steel cover. It's got a stainless steel cover on it, but this would have been, a little bit different design. better seal on the outside of it. And, it wasn't a major rehab. So then we compared all 5 of these. And what we really found is that the RTO was our best option here. What happened with the VCU is this is such a lean methane. We were pulling so much air off the BLAF tanks into such a lean methane concentration that we would actually be burning more natural gas to be able to operate the vapor combustion unit in this scenario. So really the RTU seemed to be our best case here. And then, yeah, here was what we settled on. It was either the RTO or the fixed stainless steel cover. And then when we looked at a net present value on both of them and found, that the net present value for the RTO was much, much better than the stainless steel cover. So that was what we initially settled on for the BLAF tanks. And we'll kind of come back to that at the end because that's not where we ultimately wound up. So then we looked at biosolids handling, and we looked at a lot of the same things: augmented biofiltration, vapor combustion unit, regenerative thermal oxidizer, and a vacuum extractor. So really the only new thing here is vacuum extraction on the digester. This is a really novel process. It's very interesting. It really helps with phosphorus removal because you're also creating the right conditions to precipitate out a brushite or a struvite. But what we found is we didn't have the right conditions for this product. The vacuum extractor really needs a biological phosphorus removal in your aeration basins, and we actually have just switched away from that due to expected increased nitrogen loading. So this really didn't seem feasible for our process at the time. So again, we looked back at this and we found, okay, well, augmented biofiltration, pretty good. Hey, look, that VCU that we kind of threw out in the original one, hey, that popped back up here. This is a little bit stronger of a methane concentrated stream, and it's not as much gas. So the RTO and the VCU were comparable. Go ahead, next slide, Dante. So how are we going to implement this? Well, we have a 2-phase digester system. We're one of the few 2-phase digester systems where we actually have an acid phase digester. We have 3 acid phase digesters that we cannot burn that gas or reuse any of that gas. It has to be thermally destroyed. So the easiest thing for us to do was actually to use that vapor combustion unit and pull in the biosolid stream, pull it into that and just use it there as a gas to help burn off the sour gas that we produce. Which means, and you'll see why, the BLAF tanks we're looking as a future potential upgrade to that system. So we think we've got everything handled here. Go ahead, Dante. So if we look at our 2048 do nothing condition, 131 kilograms an hour. This is super emitter territory. This is the EPA's coming to us and asking us to pay them a lot of money because we are way emitting more than we should be. But now if we start making these corrections that we've been talking about, good, next slide. If we just improve the digestion, we're down to 100 kilograms an hour, 24% reduction. That's just improved digestion. Next slide. If we fix the covers and put in the solids handling, all the solids handling gas to a vapor combustion unit, now we're down to 13 kilograms an hour. That is a significant reduction. That's a 91% reduction in our methane emissions just by doing these things. And looking future, and this is why we kind of settled with pushing BLAF out a little bit. It's only another 4% by adding the BLAF tanks into this and putting that RTO in. And it's a significant capital cost increase to add the RTO for a 4% reduction. we're getting most of our reduction, over 90% of our reduction just by doing the things we had already talked about. So this is something that we've pushed in a potential future project down the road here to see where things land. But those are the major upgrades we've done. And then as far as the bioenergy project's concerned as a whole, the 2023 condition you see here, I mean, we have a lot of purchased electricity. We have a lot of fugitive methane. And if we, by putting in cogeneration engines, reducing the fugitive methane, we've already considerably dropped our greenhouse gas emissions. And I don't have the number in front of me, but I know it's about 7,300 cars off the road per year by doing this reduction from the 2023 condition to the 2030 future condition. And with that, we'll take any questions you might have.
Yeah, that was awesome. If folks want to just come off mute to ask questions, or you can hit the reaction button down at the bottom to raise your hand. I really liked how, and Stacia said it, I think, start with what you've got, right? So that's doable for everybody. Just take a look at what you have for data to start out. Because it does kind of feel overwhelming sometimes that we're being asked to do all this stuff, and now we got to start looking at greenhouse gas emissions and but there's some good records that we have, I think, that we can get going. We do have a question from Sissy. Go ahead and unmute.
Yeah, great work at Columbus. I was wondering, are you guys thinking about co-digestion and taking the food waste to increase that or to achieve net zero?
That's a great question.
Yes, so that is something that we have evaluated for sure, because we're actually in the process of bidding our CHP facility, and that is a consideration we put in there for fog and food waste. We hope it's something that we can do, if not immediately in conjunction with the project that's currently out on the street. Definitely something we want to do in the future, and we've already talked extensively with the folks that run our landfill, which is more of an authority, and the city of Columbus doesn't actually own the landfill. But they're all in, and they have a huge food waste diversion program. They're composting a lot of their food waste, and in the future, yeah, we hope to take some of it at our facility as well.
Yeah, especially right now, the renewable fuel standards with the RIN number change, so probably will be a huge benefit to do that.
Yeah, for sure.
Thanks.
That's great. Yeah, that's great. Forward thinking. Got another question here. What are the anticipated operating cost advantages of adding CHP in the future?
Well, I guess I can tell you, CHP is moving forward. It's a current project that is being bid right now, and it was always something that was in our, future plans. We actually have CHP engines that are already constructed at our other plant that are getting ready to go into operation. And, Southerly was at some point going to be heading down that same path as well. We spend, I don't know, about blanket on the number here. It's something like $500,000 a month in power costs. And we know that the vast majority of that is, our blowers and, just it's
Creating air
process, right? It's a very costly and power intensive process. So being able to use that gas that we're flaring, right now, and actually turning around and using it to generate about half the power of our plant overall, that's going to be a significant return on investment in the future. In addition, our current CHP project at Southerly, it was supposed to be several years down the road, but then the government, issued the Inflation Reduction Act and actually put a lot of funding out there for renewable energy sources. And so we are actually seeking out funding as a part of that project that will be utilized to offset those costs. Up to 50% of the qualifying costs on the project will be paid by the federal government. So you factor that in, and our return on investment becomes pretty significant overall.
Yeah.
And you factor in the greenhouse gas reduction on top of that, and that's almost priceless in and of itself.
A lot of great incentives out there right now, for sure. Tracy.
Yes. So I was just wondering if you had looked at any methane production pre-digestion.
So, I mean, we examined our solids area, you know, specifically as a part of this analysis. You know, just we knew that was going to be the area we were going to find the most methane, right? So we are going to continue to evaluate our plant further in the future. We will look at methane too, but we're going to look at more of, you know, the greenhouse gases that we know are going to be existing, you know, within the other parts of our facility, like you know, nitrous oxide. So that one will be a big one that we'll be focused on next. Don't know exactly what you can do about that. That's a huge one. And unless we're going to cover our, you know, aeration tanks, I mean, there's not a whole lot of options out there, but at least we can understand what we have. And then, you know, as technology progresses and ideas come out there, we can at least be ready to try and address that as well.
Yeah, and get a heads up on any surprises that might be await you out there.
Well, and to
Did
your,
I?
oh, sorry.
Go ahead.
I was just going to expand on Tracy's question. So, and as Stacia had indicated, we definitely focused. We had our focus areas in the solids area. We did look around. We sniffed around, and at Southerly, we didn't find a lot else. I mean, we went to their odor control for their headworks facility, for example, and that also takes from all their gravity sewers, and that's a whole other conversation. So we looked and we didn't find it. Doesn't mean it's not there, but we didn't find it. Southerly. We have done about 15 other facilities so far, and there are times where there is methane outside of the solids area that we have found. And usually it's related to, like, if you're downstream of another wastewater plant that, you know, sends their biosolids through the gravity sewer, for example, or there's some unique situations about fermentation going on in secondary clarifiers or in the RAS. There's specific examples where we have found it, but at least right now, with our best knowledge that we have, I would guess over 90% or more is in the solids area and it's post-digestion. One thing that's super interesting, I was just talking to Grand Junction in Colorado. They have aerobic digesters, which we have never done before. So that's, we were talking about, well, that'll be interesting. I wonder what we're going to find. I have a feeling we're going to probably find some, but we don't really know. So there's still a lot to be learned, Tracy. Anyway.
Well, maybe Dante, you can come back next year when you have the findings for that aerobic process.
Absolutely.
Someone is again asking, I know that you're saying your biggest bang for your buck. I think that you got a handle on that already. But what about measuring methane emissions up pipe, like in the sewer system? Anybody doing anything like that?
So actually, Brown and Caldwell we are doing a WRF Water Research Foundation study, and Columbus is a contributing utility, and there's a few others.
Of course they are.
Yeah, I think Louisville MSD is the leading utility, and we're looking into it, and it makes me uncomfortable, to be honest with you, because there's more that we don't know about it. It's more unknown, and there's less that can be done, in my view. So it's just scarier. So the reality is I don't think we know a lot about it yet, and it's just kind of like a wait and see mode. There certainly is digestion going on in the collection system. I think we all understand that. But how much can be done is an unknown. In general, I think the prevailing thought that I've heard from all the people who really get involved in the weeds, John Willis and Trung Lee and others that I talked to, there's more going on at the wastewater plant, but it's an issue.
Yeah, and one of the areas we did kind of pick up a whiff of, you know, pun intended, testing was that we did see a plume that was coming from the west over to our plant. Well, on the west side of the river, on the other side from our treatment plant, is our biosolids composting facility. So we know something's going on over there. Now, the good thing is we're actually doing some rehab at that facility right now. We have aerated piles, and then we have static piles that just sit. And so we are actually we're working on a project to actually get all of our piles aerated. So we're hoping that, you know, whatever methanogens were over there working their magic in these static piles, that will actually be creating a little bit more aerobic conditions and hopefully curb that methane production as well that might be going on there.
Yeah, and so if you're measuring methane from storage piles, nitrous oxide data would be great too, Stacia, that we can incorporate into the beam and make that better, more accurate as well.
And
Yeah.
that's a little plug. We are doing that. We're doing next week, Stacia, or maybe 2 weeks from now.
Next week, yeah, I thought.
I haven't thought
Wow.
that far ahead. But yeah, next week we're going to be doing the same investigation at their sister facility, Jackson Pike. I don't know, Stacia, if you want to.
Yeah, we're gonna be doing all the same because we had same process set up there. But we're gonna be digging a little bit deeper to actually, grab the nitrous data as well, while we're out there, just plug another sensor into the old a drone, I guess, and see what data we can gather there too. So that is, and then go back. I think we'll go back down to Southerly and getting more data too,
We're gonna
right?
have a couple more days. We're hopefully, weather permitting, we're gonna have a couple of extra days, and my hope is we can either go to back to Southerly and see what we found again, or take a little trip to Compost. That will be depending on what the assistant administrator wants to do, I think.
Mm.
Now, is Brown and Caldwell
she said.
managing all this data for you? Like that's a lot of data that you're getting and looking at, and
Yes. So under a couple different contracts that we have, but once we did the analysis at this facility, I mean, I could not look at the other facilities, right? Like it's good information to have, and we're also amid a design project to rehabilitate our digesters at our Jackson Pike facility as well. They currently are membrane covers on those, and I am very curious to see, and they're, memory, I mean, they only last 7 to 10 years, but I tell you what, they don't get changed out every 7 to 10 years, that's for sure.
no,
So
we know.
very curious to see what is happening there today, because we've already selected, concrete fixed covers for those tanks. So we know we're going in that direction anyway. We've learned, we know what we need to know now, and we've already have a cogen facility there. So we're going to capture more gas, but it's gonna be fun to gather the data today and then, go back and gather it later once we have our fixed covers on, and then report back through our climate action plan how much the wastewater side of our city is actually helping reduce our greenhouse gas emissions as a whole as a city.
Yay. We are running out of time here, but Dante, if you could like say one or two of the most important things for designers of these systems into the future, what are some of the things we should be looking at as designers?
Awesome question. And I would expand it, not just designers, but also utilities. You hit at the point that I think is the most important. There's problems, and Columbus is super innovative, and they're addressing the problems that they have. And I don't think every utility is going to do that, or at least not until there's regulations driving them to.
Sure.
But the one thing we got to be sure as designers is we're not making the same mistakes that we've made now that we know. And so, yeah, Brown and Caldwell, we've totally changed our standards. We don't want to make the same mistakes we made before. And if there's one thing that folks on the call can take from this is, as you're looking ahead, besides just considering this as part of your capital improvement plans, making sure that you can spend maybe no more money at all, and just make smart choices about how to mitigate emissions. That's probably the easiest low-hanging fruit that you can get out of it.
Yeah. Don't install floating covers on your digesters. Just
Okay.
don't. Right.
Don't do that. Yeah.
Just don't.
All right.
too.
That's a pretty straightforward one. Yeah, that's awesome. Well, thank you so much, Stacia, Tyler, and Dante. And yeah, thanks to everybody for joining us today. We won't be meeting again till 2025, but up on our netter lineup next is we're having Professor Jeff McCutcheon from UConn come back to talk to us about that SCADA system he's trying to design for AD operations. That's something getting funded by USDOE and their decarbonization grant program, which there's a lot of money out there right now for that as well. But if anyone has any suggestions for something you want to hear about next year, please let me know. And thanks to all of you for joining us today. Again, thanks, City of Columbus, you go.
Thanks, everyone.
All
Thank you.
right. Thanks. Just save this chat. Thanks again, Tyler.